Welcome to CSE 160, Introduction to Programming Using Python. We're going to learn how to write computer programs this semester and learn a little bit about how to think like a programmer. We'll in a separate thing, we'll familiarize you with the syllabus and all that sort of, the trappings of the course and how to access all the various materials that you'll need. But let's just start in on this idea of programming and in this introduction, and there will be, we will have some sort of homework or quiz questions or some kind of evaluation on this lecture. So because it's important to know why we program and what it is we're actually doing. It's something that we do actually more often than we realize. Many years ago, I guess now we could say 50 years ago, this being 2022, a geology professor talked to my class about the idea of classifying things and organizing things and, making sense of how things are in certain classes and how things are the same or different and how we might, sort of track that with naming of things and recognizing their properties. And there's a lot of that in programming, but even more so, he felt there was a lot of philosophy behind that. And this quote is from him, a Australian bloke, if you will. Humans are the only species we know of that thinks about thinking. And, maybe that's changed, but I believe it's still true. And when we think about programming, we have to think about thinking. We have to think about what it is we're trying to achieve and how we're going to go about it. And, are we creating something? Are we reusing something? Do we know what the substances are? If you want to call it that, the data or whatever it is that we're going to use in this program. We know that we have to think about that stuff, and we have to organize our thinking into some kind of a recipe, if you will, a sequence of steps that we're going to do in order to accomplish what we want to do. And so the Python programming language is something that we're going to use for that. So towards programming and what is it? When you work to solve a problem the first time, you are problem solving. We do that all the time. In fact, animals do that too. If you've ever seen those movies about crows or ravens, they use tools, they learn things, they do a lot of amazing thinking about problem solving. When you tell someone else the sequence of steps to solve that type of problem, you are programming. You are providing that sequence of steps, that algorithm, if you will, or that recipe, a word I just used before. You are programming when you organize the steps to solving a problem. And programming is a kind of automation. Lots of things that were made before the Industrial Revolution were made one at a time by hand. And when we got to the Industrial Revolution, we began to learn all this stuff about interchangeable parts and how to, produce things in a more automated fashion and then be able to, assemble things out of these parts that we made and standardize some of the parts. That's all an automation, and programming stems out of that entire growth of a thinking about automation that our society has developed. You think about you think about automation and you think about the assembly line. Well, the different steps of a program are kind of like an assembly line, and a program, might run repeatedly, calculating new information for each employee in a company, or calculating and displaying position and velocity information for all the airplanes in the reach of a tower for an airport or something like that. All of these, all this repetition and automation is, it's kind of the spirit of what we're doing. So automation can be a really good thing. Now you can automate things and produce low quality results, or you can automate things and produce very high quality parts. The automation being the very mechanism which produces reliable and quality parts that are held to tolerances, that are, all the measurements are very close to each other and all that sort of thing. Well, the same kind of thing happens in programs. We can run programs and calculate employees' paychecks, employee by employee, or taxes, or we can we can do these things, and they need to be done quickly. Perhaps doing them in real time with humans on calculators is not possible. The programs may have to run very quickly, and that's what programming gives us. It's just a way of automating things as we've been doing previously, but there's so much power in it and creativity. So we're going to keep that as we go forward. Now, programming is not a new phenomenon. As I said, goes back to before the Industrial Revolution. Here we are, 1804 is pre-Industrial Revolution, and we have a loom. And if you are familiar with a loom at all, this particular red thing here is I believe called a shuttle, and it carries the thread across the loom. And in the loom, you can raise and lower these strings that are vertically arranged here, so that you can go over and under and over and under and that sort of thing. And you can see this fabric is partially woven down here. Oops, that is my bad. Sorry. Let me go back. There we go. And so this weaving that is accomplished on a loom is done by maybe as simple as raising every other thread, and so that there's space between, say, the odd numbered threads and even numbered threads, and you send the shuttle across. I did it again. You send the shuttle across, and a string goes there, and then you lower the strings that you had raised before and raise the strings that were lowered before, and you send the shuttle back across, and so you wind up, and with this comb type of thing, you can pack down the threads, and you can weave cloth that can be used for any number of purposes. So this very enterprising fellow here, Jacquard, he decided to automate the production of things on a loom, but in order to make fancy patterns that were desirable and that people would buy, he created these cards, if you will, and the holes in the cards corresponded to threads that would be lifted, and the shuttle would go across and go over or under the appropriate threads. And also they could send different colored shuttles across. And so this was all automated in these pieces of cardboard. And you can see there's sort of a string type affair here, a cord of some kind that chains them together. And they go through the machine, and and basically tell the machine how to weave the fabric, which threads to lift or not lift, and which shuttle to send across with which color. And they could make very ornate things, and all of a sudden you had more productivity of valued woven fabric and patterns and that sort of thing. And of course, people will pay more money for that, and on and on we go. But this is an example of programming in a machine. And so if you have this one machine, but you can have several of these books, or whatever you want to call these groups of cards that are strung together. You can have one to make a floral pattern. You can have another one just to make a classic zigzag kind of pattern, or whatever pattern it is that you want can be programmed on here. So now the machine becomes more flexible because we can program how it's going to work. Someone still has to set up the various colors of thread and do the machine and everything. But for 1804, this is an early example of of actually making something more flexible by making it programmable. All right, so there you go. Let's see. The player piano. We have these YouTube things here, and I think we can take a look at some of this. And so this is
secrets. The music box is the comb. I'm sure you've done this many times before.
Yeah, but I'll spare you that. But basically, I think this is, I said player piano, but this may be the music box. And this is where someone has, he puts out these various...
strange effect. Watch this.
He puts out these tines.
Well, if you had a whole lot of hack...
And a music box has all these tines. Sorry.
Welcome to this music box programming tutorial. This is a 30-note music box programming tutorial. This is a 30-note, and when you program longer songs on these music boxes, like this one, it will drive you crazy in no time. It is quite daunting sometimes.
So what he's doing here is he's punching holes in different rows with different timings, and they go through this music box mechanism, and they hit little tines of different lengths to make notes, kind of like chimes of different lengths to make notes. And so this particular mechanism is programmable. You could play nursery rhymes or other versions of other songs or whatever. Again, the machine is the same, but what can be produced by it is programmable. There's more flexibility here because it has this programming capability. So let's see what else we can find and get ourselves in trouble with here. This that's the music box ones, and the player piano. This is obviously from how it's made, and
the first self-playing piano system was invented around 1895. It sat in front of a regular piano, and the machine's wooden fingers would play the keys. Guiding those fingers was a roll of perforated paper. By the early 20th century, piano companies incorporated the roll mechanism right into the piano itself.
So
the player piano rage petered out around 19...
As you saw in that video, let me see if I can
but there are still plenty
get back to the zoom in place.
Around 1930, but there's...
So this bar has air flowing through it, and it has all these little holes correspond to notes on the piano. When these particular cutouts in the paper, these holes go by, the air comes out and it allows that note to play. So it's, another form of music box. But this is, again, a programmable instrument. So someone has a player piano, and then they get these rolls, and you can have whatever song you want on these rolls, and you can play it and listen to music. And that was, I guess that was the MP3, song player of the 1905s. This is flexibility added to a machine, and so that it could, in this case, make songs. And I don't know, call me crazy, but sorry, call me crazy, but I like that. I think that's a really cool example of programmability. And so someone has to locate the holes on the paper roll so that the paper roll passes through the mechanism. And I guess I missed a word here or something, and the correct tines through the mechanism, the correct tines to play the desired tune, whatever I was trying to say there is the paper roll has these holes in it, and the correct notes will play the desired tune. Same thing up here. I guess there's a copy and paste mistake. Sorry about that. But if you've ever seen a music box, there's a metal drum and there's little metal tines on there, and maybe as a little ballerina dances on top, something that you wind up with a key spins, and the drum has these little cams on it, and they hit those little metal tines and they play the desired song. And you can, you could put a different drum on there and play a different song. It's it's essentially programmable. Typically, you buy the music box with one drum in it, and it plays a particular song. But the manufacturer can make a number of them and play songs that are for any occasion, and people can buy them. So that dates back even before the Jacquard loom. 1770 in Switzerland is about when those things started. So let's so how important is programming? Let's look at some quotes here. Professor Begas gave me these quotes, and they're really good. I want to include them. So whether you want to uncover the secrets of the universe or you just want to pursue a career in the 21st century, basic computer programming is an essential skill to learn. This comes from someone who has done a lot of work and had a lot of success at working to uncover the secrets of the universe. So Stephen Hawking, he's a world-renowned theoretical physicist and cosmologist. And here's one, Steve Jobs, okay? He co-founded Apple, so Macintoshes and iPhones and Apple Watches and, all the things that Apple prides itself on. Everybody should learn to program a computer because it teaches you how to think. And this goes back to our first slide. Humans are the only species that thinks about thinking. So in order to program a computer correctly, one needs to think about their own thinking and saying, am I approaching this correctly? Am I sensible in what I'm doing? And that all requires thinking about thinking. And in learning to program a computer, it forces you to examine how you think and to improve how you think. And so we all agree with Steve Jobs on this one. You can like him or not like him, but he hit a solid truism right there. And Elon Musk, again, you can have your opinions about Elon Musk. I kind of like him. I taught myself how to program computers when I was a kid. Bought my first computer when I was 10, and sold my first commercial program when I was 12. Okay, so he's pretty advanced in this thing. But if you look at the Elon Musk, the CEO of Tesla and SpaceX, and I think he helped create PayPal and a couple other things before he went on to these things. He was an avid gamer as a kid, but couldn't afford to buy the latest video games or consoles. So I suspect he programmed some things and kept himself occupied with that. And he seems like someone who does know how to think. So yeah, I'll let Elon Musk speak for himself. He's you know, his companies are building rockets that are taking astronauts to the International Space Station and eventually farther than that. He's launching satellites and landing his main boosters back on a pad, vertically. And yeah, okay. I don't think I need to sell Elon Musk creativity or power as a thinker. And so a couple other quotes here. Bill Gates, Microsoft co-founder. I think it's fair to say that personal computers have become the most empowering tool we've ever created. They're tools of communication, they're tools of creativity, and they can be shaped by their user. And I have to admit, that is one of the reasons that made computers so attractive to me, is that you could make them do all these amazing things. And the computers can communicate. A lot of my career was spent as a hardware engineer designing communication equipment for computers. They're tools of creativity. Most people who do program love the creative aspect of it. They love the problem solving and the tinkering with programs and that sort of thing. And by doing that, you're shaping them. The user, you're not just they are a tool, but the programs are tools themselves. In fact, people refer to programs as software tools. There's a Brian Plauger formerly of AT&T Bell Labs, who wrote a book called Software Tools. And it was about the kinds of programs that one might write that they use over and over again to write more powerful programs. So there's just a lot of power. There's power in tools, and when you can reuse tools and you can put tools together, you wind up building some very powerful things. And this one from Reshma Saujani, the founder of Girls Who Code, and Hour of Code and that sort of thing are all related to this, if you've heard of any of those efforts. Coding is the language of the future, and every girl should learn it. As I've learned from watching girls grow and learn in our classrooms, coding is fun, collaborative, and creative. So there's the creative part again. And there's fun and creativity. Collaborative, the big programs that are written nowadays are written by teams, and people have to work together. And so it's it's a people-oriented business where people are working together and sharing ideas as well as the work. It builds intellect. I really believe that. Coding is the language of the future. I think we've all already seen that we are programming things to various extents. The things we buy nowadays are programmable, and they have all sorts of configurations and flexibility. And so I think everyone watching this lecture has experienced some degree of, configuring things and programming, if you will. Now, one thing I want to say here, and this is important. This goes toward vocabulary, and I didn't put a slide on it, so expect to be asked about this in a homework or quiz or something. When we write programs or we gather data and we store that kind of stuff in a computer, programs and data are called software. They are not something you can very easily touch. And of course, disk drives, thumb drives, keyboards, mice, monitors, computer towers, or laptops, they are all hardware. The networking boxes that you might experience in Cisco classes, that is hardware. But the Cisco operating system that you have to configure on those network boxes is software. So it's good to make sure that you know those two terms, and it may seem trivial, but people sometimes kind of confuse those terms. Make sure you understand that software is the programs. If you look at something like a smart TV, that smart TV is hardware, but Netflix and Amazon Prime and whatever streaming services, those are software, and they deliver software. The TV programs you watch are software. The TV on which you watch those programs is hardware. So in this automation we talked about, IT professionals support complicated arrangements of computers and networks. Some tasks or problem fixes are one-off. That is, one only faces them once in a great while. This is kind of like in that early slide we talked about problem solving versus programming. So that sort of problem solving. But there are many tasks that are repetitive. You're backing up computers and servers or network configurations or any kind of thing like that. You're running test programs to see that everything is working properly, that you can reach all the computers you're supposed to reach over your network. So these repetitive tasks are performed repeatedly, and the steps could lead to mistakes whose consequences are significant and aren't realized till much later. So, you're doing certain backups or checking configurations, and someone happened to change something, and or somebody made a typo when they typed something in some backup step to save programs, to save software, to save data. Someone might make a mistake in that, and it seems like everything went fine, but then later on, when it's much more difficult to recover from the error and someone needs to, they find that, that wasn't, there was a problem in doing that. But if you automate that, remember how we talked about automation producing quality results in, quality and quantity. A great protection against the errors that come from mind-numbing repetition is automation. If the steps of such a task can be scripted, you may hear that word scripted, and it's just another word for programmed, really. The process can be repeated as many times as desired without error. That is, assuming you haven't created an error in the script or program you created, and that needs to be tested. Obviously, that then it would produce an error every time you ran it. But a lot of things can be automated using programming, and it reduces errors, and it also frees you up to concentrate on the things that really require human mental processes to analyze and decide how to approach. What have we got here? I guess that slide seemed to be out of order to me, but how do programs run? Just from a simple standpoint here, we have a computer. It could be a laptop, it could be a desktop or kind of a tower, or it could be a server computer. But we always have a central processing unit, which is an integrated circuit. And you've seen this kind of thing in CSE 110. We have a mouse and a keyboard, which are input devices. We can store programs and data on a hard disk drive, or maybe a solid state disk drive, whatever technology you happen to have. We have memory. If you remember the DIMMs that you plugged in, this memory is read-write memory, and this is like a giant blackboard for whatever the central processing unit is doing, so it can keep track of partial results and notes and that sort of thing. And the programs are also executed out of this same memory. So when you want to run a program, it is located typically on hard disk, downloaded into memory, and then the central processing unit runs that program, and it may take input from keyboard and mouse, may take some more input from the hard disk drive. Perhaps it reads files or something. It may interact with the network, and maybe it gets information from websites out on the network. And it can, of course, produce output on the monitor, or play a song or something on the speakers, or what have you. And then, there are some computers where this output goes out to machines, and some of the input actually comes back from the machines, and the computer controls machines. So this is I just want to rehearse this basic concept, so when people talk about DRAM memory, or the DIMMs in your PC, this is the memory where your programs and your data are going to sit while they execute. And you'll be seeing you'll command your program to to display information on a monitor, or do something as a result of your programming, your writing of that program. You may take input from the user. You may read a file in. You might look at a website over the network, and then you might write back to the disk drive the results that you had, and maybe also put them out on the monitor. So that's all up to you. But this is actually what happens. Just like when your computer boots, it loads a program from the disk drive into the memory. It loads the operating system. And all that does, that's a program that helps you use all this other stuff. And so you use programs to write programs. You use the operating system to help you access the disk drive, or the mouse and keyboard and the network and all that sort of thing. And then when you tell the operating system, would you please run my program I just wrote, it's going to go get the program. If it's been stored on a hard disk drive, it'll get it from there, or maybe it's been written in memory. It will execute your program right in memory and perform whatever it is you tell it to perform. And hopefully you'll learn to tell it the right things. Now, if you tell it the wrong things, typically in the program environments we run, you are pretty insulated from doing any harm to the computer. You could delete files and that sort of thing, but there's a lot of protections there. So I would really encourage you to try, as you learn about programs, to try programs, and the environment that we are going to use will enable you to do that in a safe manner, and see how the Python programming language works. This is just references to where I got those pictures of the Jacquard loom and the other stuff from. So there you go. We're going to think about thinking, and we're going to think about the thinking that goes into programming. Welcome aboard and all that, and I think you're going to be pretty pleased when you see what your programs can do, and how much creativity is afforded to you when you program. All right, we'll see you again soon, and thanks for watching this. And like I said, we'll be, getting you information about how to access the course materials and all that. So let's have some fun. All right, bye.